Continuing on with our notes from section 4.3, we took a look at a second example. These problems can be rather long. We found all asymptotes, we found a hole, we found x-intercepts, y-intercepts, but maybe one question that we really should still address is, how do we know if our function is going to cross our horizontal asymptote? Remember, we found our horizontal asymptote was A2 for this problem in class. It's this dotted line right here. But look, in our previous problem, we saw that our curve very well could cross the horizontal asymptote and then come back and then never touch it again. Maybe a big question is, how do we know that perhaps way down here at 100 or somewhere else, that the curve might cross the horizontal asymptote, rise slightly above it, come back down, never to touch it again? Well, what you can do to determine if this is going to occur is investigate if your function, I'm going to recopy it right over here, could possibly equal, notice I'm not even factoring it out, certainly we could factor it. This is a y value of 2. You might wonder, is this possible for this rational function to equal 2? Now when we cross multiply, it's going to appear that perhaps it will. Look right here, something nice. I can subtract 2x squared from both sides. Solving for x, I'll minus a 2 from both sides to get negative 10 is equal to negative 5x. If I divide by negative 5, I will get x is equal to 2. However, that's where we had a hole. What we're seeing is this doesn't make sense, of course. Obviously, our function is not crossing our horizontal asymptote here. There are no other x values that would make this fraction equal 2. We can see some very strange behavior sometimes, a solution that appears to work. But remember, if we were to plug 2 into this right-hand side, our function would be undefined. Really, we would not equal 2. So rest assured, our curve will not cross our horizontal asymptote. Quickly, let's look at the other side. Maybe working through example 4 in more detail. Coming back to example 3 in just a moment. But of course, we would like to see if we could find vertical asymptotes, horizontal asymptotes, oblique asymptotes if they are present at all, a hole if it could possibly exist, an x-intercept, perhaps a y-intercept, and thankfully everything in this function, for example 4, has been factored out. Nothing will cancel. No terms can be canceled out. That means there is no hole. There is no hole whatsoever. Vertical asymptotes, though, if we pay close attention, we're looking at this denominator, we can see very quickly that we would have 2, that x would equal 2, and also that x would equal 1. For our horizontal asymptote, we need to investigate a limit. As x is getting very, very large, this function, we can look at the top and see what end behavior model is really applying. X plus 1, well, the end behavior model would be an x, so the top would be behaving just like this. Down below, look at the degree. We'd have x squared and an x. That would become x to the third. Of course, this would cancel out. X over x to the third is 1 over x squared. But we've said 1 over big is small. This is going to 0. Again, be careful. We're going to say y equals 0. Remember, if your degree is smaller on top than the degree down below, or even if it's equal to it, you will have a horizontal asymptote. You may find it via the limit. That means you do not have an oblique asymptote. X-intercepts, well, let's just check out the top here. Take a look at this numerator. You ask yourself, where is that 0? The answer is -1. Obviously, when the top of a fraction is 0, the entire fraction becomes 0, meaning y is 0. To find the y-intercept, well, we let x is equal to 0. Up on top, we'll have a 1. -2 squared is going to be a positive 4. But then we're going to multiply 0 minus 1, -1. So we'll have a -4 down here. We can just bring that out in front. Alright, well, let's go ahead and quickly make ourselves a little sketch. It looks like we're going to have a vertical asymptote at x equals 1. Make that dotted. Looks like we will also have a vertical asymptote at x is equal to 2. Very close together, you might notice. Y equals 0, we're going to have our horizontal asymptote. Well, we are going to cross that horizontal asymptote. We're going to cross at x equals -1. And that can get rather interesting. Sometimes you might wonder, well, I wonder if we're ever going to cross the x-axis again, cross this y equals 0. We could investigate this right now. Look, here was our f of x equals x plus 1 all over x minus 2 quantity squared times x minus 1. If I were to let the left side equal 0, and if I cross multiply, look what's going to happen. You can rest assured that as we cross multiply, you would just have x plus 1 equals 0. Solving, we'd get x equals -1. That's the only x value that we're going to have where we will cross that horizontal asymptote. So good news there. Y-intercept, well, it looks like we're going to be over here at -1/4. Let's see, other things to talk about. Well, look what's happening at x minus 1. We talk about the multiplicity of it. X minus 1 has an odd power. When you have odd powers, what you're going to see is that your curve is going to be going towards positive infinity on one side, negative infinity on another. Now you could really quickly make yourself a tiny table and investigate what's happening. Like you could say, what would happen if I'd plug in 0.9? Would I get something positive? Would I get something negative? Well, look on top. 0.9 plus 1 is positive. Hey, anything squared will always be a positive. 0.9 minus 1 is something negative. So I know I'm going to be going towards negative infinity. And it certainly looks like this is the behavior of our curve from the left. We know we are going to be asymptotic. Our curve will get closer and closer to y equals 0, but we also know we're going to cross. And just by looking at those 2 points, you might think, hey, we'd be approaching negative infinity from down below. Okay, well, what if we plugged in 1.1? Well, again, this is an odd power. We would expect this to be going up, going in a different direction as we approach from the other side, just like the Kung Fu Fighter graph like we were talking about. Well, hey, double check. Plug in 1.1 into all of these factors. They're all positive. Sure enough, that's exactly what we would see. From here, you might wonder, well, I wonder what's going on around 2, x equals 2, especially because now when you look over here, you can see x minus 2 is raised to an even power. Remember, that was a volcano graph when we saw a squared term down below. A squared term means that our behaviors are the same when we approach that number from the left and from the right. Now, we can confirm that super fast. And by the way, when we plugged in 1.1, we said we were positive. Might say, what's happening when we plug in 1.9? Well, when you plug in 1.9, the top term is positive. Down below, we'd get something positive. And 1.9 minus 2 is negative, but we square it. You know what? We're really going to be approaching positive infinity. You might think, well, what if we went just a smidge to the right of 2, like at 2.1? Same thing. Look at each of these factors in our function. Each one is positive. I know my behavior is going up towards either positive infinity or negative infinity. The positive says that's the case. Now look, we know that this curve is going to be coming down. We know that we're asymptotic to y equals 0. We also know we're not going to cross. We know we're never going to cross, because otherwise we would see other x intercepts. We only solve for one. We can also plug in the horizontal asymptote into the curve like we did. Rest assured, it's not going to ever cross again. By the way, that's where even on this left side, sometimes kids might be like, wow, how do you know that this right here won't cross down again? Well, remember, we solved for that at the bottom of the page. There's only one place where that function could cross y equals 0. It won't cross again. Otherwise, we'd also have x-intercepts, more of them. Well, you know what? You might wonder, well, I wonder what this behavior is. To really gear up and find out where we are, we could plug in 1.5 and find out how low we're going. Honestly, that's not even necessary. We could, at this point, have a very good idea for a curve. If we were asked to put more detail in, certainly we could plug in 1.5. We can even plug it in right in here. 1.5 plus 1 up on top would be, 2.5 and so forth. Just crunch that out and you'd have a good idea. But there you go with a pretty good approach to graphing these things. Take a look at example 3 with me just very briefly. For example 3, of course, we could factor the top into x plus 2, x plus 1. I just want to make a quick comment that there's no hole. Nothing is canceled out. You can say, well, what about a vertical asymptote? Well, there's only one vertical asymptote here, only one term down below. Set that equal to 0, you'd get x equals 1. Look at your degree, though. Look up on top. This is a 2. Down below, you'd have a 1. When the top degree is greater than the bottom, there is no horizontal asymptote. That's none. Instead, we're going to find an oblique asymptote. The oblique asymptote, remember we found this the other day, we can do division to get that. And just reapproaching this, hopefully this is going to go a little bit quicker. Look at these leading terms. What times x is x squared? Well, an x. Multiply to both. We'll have x squared minus x. Well, then what do? Well, we change both sides and we add. This first term cancels out. 3x plus 1x is a 4x. Then we play the matching game once again. We'd say what times x out in front would get us 4x. Thankfully, we just have this last step. We have a plus 4. We have to distribute. We get 4x minus 4. Here we go again. Change both signs. This is gone. 2 plus 4 is 6. Now, right now, you could say that the quotient is x plus 4. The remainder is 6, but we'd write it as 6 all over x minus 1. But it's only the quotient that we really have to be paying attention to. If you wanted to make a super quick graph here, we're running out of time, we know that at 1 we're going to have a vertical asymptote. If we go just a smidge to the right, like at 1.1, well, positive down below, that's positive. We know we're going to positive infinity. Plug in 0.9, everything's positive up on top, but down below it's negative. We know we're going to negative infinity. We also have this x plus 4 with a slope of 1. And I think you can see what is going to happen here. your curve is going to look roughly something